Now today's lecture is based on acidity of carboxylic acid, right? So in the earlier lecture we talked about the synthesis of carboxylic acid. Now in today's lecture we will be discussing about acidity of carboxylic acid, right? Now how can you define the acidity? How we define acidity? Any substance which can donate H plus ion, right? We call it as an acid. Fine. And a जो भी कोई substance होगा, if it is capable of donating H plus ion, we say that it is acid, right? Likewise, if we talk about carboxylic acids, that is R C double bond O right? Fine. Here in case of this RCOH, we have OH bond. Fine. Now, what is the possibility here if we treat this carboxylic acid with water? There is possibility of cleavage of this OH bond. Fine. And this, it will release H plus ion and will be taken out by water. Because we have lone pair on the oxygen. Fine. This will be taken out by this H plus ion will be taken out by the water and you will get R C double bond O minus plus HCO positive ion, hydrogen ion. You got it?
Yes, sir.
So what happens here? There is cleavage of OH bond, H plus ion is released, which is taken up by the water molecule to get converted into hydrogen ion. And it is released here H plus ion, right? This is the carboxylic acid, it changes into carboxylate ion. Carboxylate ion. Now, why these carboxylic acids undergo this OH cleavage? There should be some driving force, right? You got it? The driving force is the resonance stability of this carboxylate ion, right? Let me draw it once again. It is R C double bond O minus. Now see, there is possibility of resonance stabilization. See, this is O minus. Here you have C double bond O. So there is possibility of transfer of these two electrons to oxygen. This carbon will get positive charge. Now this O negative will come down. So there is sort of resonance stabilization, right? And a new resonance structure will be R C O minus. Now this will change to double. So these are resonance structures. You got it?
Yes, sir.
You got it? So that's why these carboxylic acids undergo OH bond cleavage to give carboxylate ion, which is resonance stabilized. So that's why these carboxylic acids are acidic in nature. अगर आप लेंगे ना carboxylic acid, aqueous solution, उसमें डालिए आप pH paper, ठीक है? आप डालेंगे paper strip, pH paper. Now acids have the property they turn what? Blue litmus paper to red, right? If you dip blue litmus paper into aqueous solution of carboxylic acid, it turns into red. So that means they are acidic in nature. Here is presence of H plus. You got it? So the driving force for these carboxylic acids is that there is loss of H plus ion to form carboxylate ion, which is resonance stabilized. So this is the driving force. And let me tell you, these carboxylic acids are more acidic than alcohols. They are more acidic than alcohols. So these are resonance stabilized. This carboxylate ion is resonance stabilized, and you have to remember is that these carboxylic acids are more acidic. Carboxylic acids are more acidic than alcohols. More acidic than alcohols. Okay? Now we have to find out what are the factors which affect the acidity of carboxylic acid. कौन से वो factors हैं जिन पे किसी कार्बोक्सिलिक एसिड्स की जो एसिडिटी है वो डिपेंड करती है, right? There is generally two factors we have. The factor number one is factors affecting acidity of carboxylic acids. Acidity of carboxylic acids. Number one is nature of group attached. Nature of group attached to COOH group. कार्बोनिक एसिड जो ग्रुप है COOH ग्रुप, उसके साथ कौन सा ग्रुप अटैच्ड? व्हाट इज द नेचर ऑफ द ग्रुप अटैच्ड? यू गॉट इट? सेकंड थिंग, number of groups attached. Number of groups attached. एक तो कौन सा ग्रुप अटैच है, दूसरा है कि कौन सा, एक तो कौन सा ग्रुप है, दूसरा कितने ग्रुप अटैच है, राइट? सो ऑन दिस टू फैक्टर्स वी कैन प्रेडिक्ट why these carbonic acid, which carbonic acid is more acidic and which one is least acidic, right? So generally I can show it like this. For example, if it is group G, it is attached to COOH group. This is carboxylic acid, right? इस carboxylic acid की acidity कितनी होगी? So that will depend upon the group attached, right? और इस ग्रुप के कितने ग्रुप्स अटैच्ड? एक तो ग्रुप कौन सा है, फाइन, इसका नेचर कौन सा है, राइट? which टाइप ऑफ ग्रुप इज अटैच्ड, दूसरा कि वो उस ग्रुप के कितने नंबर अटैच्ड, राइट? तो उस पर डिपेंड करेगा किसी भी कार्बोनिक एसिड्स की एसिडिटी, राइट? सो लेट मी टेक एन एग्जांपल. फॉर एग्जांपल, इफ वी हैव CF3C double bond O, right? And if you write CF2H, if I write it like this, CH F2C double bond O, if I write it CH2F C double bond O. So what's the difference between these three carboxylic acids? They are all carboxylic acids, right? This is carboxylic acid, this is, and this is also carboxylic acid. Fine. इसमें कितने फ्लोरीन है? 3. इसमें कितने? 2. इसमें कितने? 1. You got it? क्या समझे? Yes. एक तो इसमें देखना है कि कौन सा ग्रुप अटैच्ड, राइट? और कितने हैं? फाइन. अगर आप यहाँ पे देखेंगे, यहाँ पे 3 फ्लोरीन एटम्स हैं. And let me tell you, fluorine is one of the most electronegative atoms in the periodic table. It will withdraw electrons. It's a very strong electron withdrawing group, right? So इस पे डिपेंड करेगा कि कितने, सपोज फ्लोरीन, if we talk about these 3 examples, यहाँ पे कितने फ्लोरीन एटम्स अटैच्ड है और कौन सा फ्लोरीन या कौन सा हेलोजन अटैच्ड, राइट? सपोज यहाँ पे 3 फ्लोरीन है, यहाँ पे 2 है, यहाँ पे 1. You got it? So before predicting its acidity, let me tell you first, you have to remember, it's a very important thing. You have to remember this thing. First thing, acidity is directly proportional to number of electron withdrawing groups. जितने electron withdrawing group ज्यादा होंगे COH group के attachment में, उतना वो ज्यादा acidic होगा. Second, acidity is inversely proportional to the number of electron donating groups. इसका उल्टा है, जितने electron donating groups ज्यादा होंगे उतनी acidity कम होगा. You got it? Yes. So what we can conclude from this is that electron withdrawing groups generally increase the acidity of carboxylic acids. So I can make it like this. Electron withdrawing group when attached to COOH group, it will increase acidity. Yes, sir. Increase acidity. I will tell you later on why. So general rule is that if electron withdrawing group is attached to COOH group, it will increase its acidity. And you have to also remember, if electron donating group is attached to COOH group, it will decrease its acidity. So this is the general rule here to remember. You got it? Yes, sir. Fine. So first thing is, acidity will be directly proportional to the number of electron withdrawing groups. जितने ज़्यादा होंगे उतनी acidity बढ़ेगी. जितने electron donating groups ज़्यादा होंगे उतनी acidity कम होगी. Fine. As we have this inverse relationship. Now the third is that if we have electron withdrawing group, so it will generally increase acidity. If we have electron donating group, it will decrease acidity. Now reason is that why you say it like this. For example, if we have, let me take an example. Let me generalize it first. If it is electron donating group, if it is directly attached to C double bond OH, try to understand. Now the property of electron donating group is that it pushes electrons towards the COH group. It will donate. यहाँ से इलेक्ट्रॉन किसको देगा? COH group. So as a result, what will happen? जब ये इलेक्ट्रॉन डोनेट करेगा किसको? COH group. As a result, जो OH bond होगा, its strength will increase. ये यहाँ से इलेक्ट्रॉन दे रहे हैं ना इसी को, COH group को. So as a result of this, OH bond will be, its strength will increase. OH bond is strong, right? So as a result, it is very tough to break. It will not easily break because we define strong acids are those acids which easily give H plus ions, while as weak acids are those acids which do not easily give H plus ions. So when this electron donating group is directly attached to COH group, it will increase the strength of OH bond. As a result, it will not break easily. So acidity will fall.
Yes, sir.
You got it?
Yes, sir.
Now likewise, if you have electron withdrawing group attached to C double bond OH, it will do reverse of it. It will pull electrons from it. ये दे रहा था electrons. Now this will drag electrons from the COH. You can never electrons, honestly. Arrow will be like this. And OH bond will be weakened. You got it?
Yes, sir.
So this electron withdrawing group will decrease this OH bond strength, and obviously will easily H plus ion will be released, so acidity will increase. You got it? So this is the reason why these electron donating groups decrease acidity and why these electron withdrawing group increase acidity. You got it? So let me directly go to the example. Example number 1. Let me be example number A. If we have this example, which I write earlier, CF3, C double bond O, OH. Number B is CH, F2, C double bond O, OH. Number C example is CH2F, C double bond O, OH. If I ask you to give a decreasing acidity order, so what will be a decreasing acidity order? Which one will be more acidic? A obviously.
Yes, sir.
Why? Because it has got 3 electron withdrawing groups, right? As a result, this OH bond will be highly weakened.
Yes, sir.
It will easily give H plus ion. So A will be more acidic than B, which will be more acidic than CZ. You got it?
Yes, sir.
ठीक है? So how we are explaining it? On the basis of number of electron withdrawing groups. इसमें 1 है, इसमें 3 है, इसमें 2 है, इसमें 1 है. You got it? Fine? This one of the example, it's very easy, right? Should I move ahead? Let me take one more example. Example number 2. Now if we have these molecules, H, C double bond OH, formic acid, one example. This is A. The B molecule is CH3, C double bond OH. Example number C is, let me say, suppose CCl3, C double bond OH. Example number D is CF3, C double bond OH. Again, if I ask you to give decreasing acidity order, what will be the decreasing acidity order? Which one will be most acidic? पहले आप मुझे बोले कि इसमें सबसे ज्यादा एसिडिक कौन होगा? D obviously, right? D, then followed by C obviously, then A, fine, then B. Can you explain it now? Why D is more acidic than all of these three? Because it has got 3 electron withdrawing groups. You got it?
Yes, sir.
You got it? Although this Molecule number C has got also chlorine, 3 chlorine, they are also withdrawn, but it is weakly electronegative as compared to chlorine, because chlorine is more electronegative than chlorine. You got it? You got it? It is strong electron withdrawing as compared to chlorine. You got it? इसकी वजह से ज़्यादा weak होगा यहाँ पे. Fine. So this will be highly acidic, followed by C. Now what about A and B, which will be more acidic? A obviously, right? Because H is neither electron donating nor it is electron withdrawing, which will be neutral. Fine. But if we talk about B, this is CH, this electron donating, because all alkyl groups are electron donating groups. If you donate electron to this COH, as a result OH bond will be strong. It will not easily H plus ion. So this will be weak acidic. You got it?
Yes, sir.
Fine. Example number 3. CH3, single bond CH2 COH, A molecule, B molecule CH2F, CH2 COOH, molecule number C CH3, single bond CHF, single bond COOH, right? D part. If we write it like this, H C double bond O H. So what will be the decreasing acidity of it? You do one thing, you make a correction here. You CF2. What will be the decreasing acidity of it? First you pick up which one will be more acidic.
C.
C. Why?
More electron withdrawing.
Because there are two strong electron withdrawing groups. You make one more correction here, so to make you understand. यहाँ पे दो, right? Now give the acidity, decreasing acidity of it. C is more acidic than B. Later you will explain it also. Fine. B. Then D. Then A. Can you explain it now? Why C is more acidic than B? This is a little bit of difference. But can you pick it up? Why is C is more acidic than B?
Because the carbon added to the carboxylic acid have direct connection with that of electron withdrawing groups like F and F.
Now, one more important thing is that you have to look out how much electron withdrawing group is away from the COH.
Yes, sir.
How much distance it is away. You got it? Fine. Now here these two electrons, strong electron withdrawing groups, strong electron withdrawing groups, these two fluorine atoms, they are just directly attached to the COH. You got it? But in case number molecule B, there is one intervening carbon, right? It is not directly attached to this carbon. You got there is one intervening carbon. It's a distance, because it's also distance dependent. I mean to say, electron withdrawing group या electron donating group कितना दूर होगा COH group से? How much distance is there? If it is away from it, because I told you there is distance dependent. These some effects are distance dependent, right?
Yes, sir.
So because I told you in inductive effect generally distance dependent, because there we have got minus sign inductive effect and plus sign inductive effect, right? जितना group दूर होगा COH group से electron withdrawing उतनी उसकी एसिडिटी इफेक्ट हो जाएगी. यहाँ पे ये नजदीक है, राइट? सो इसका फुल ज्यादा इफेक्ट है, राइट? यहाँ पे थोड़ा एक इंटरवीनिंग कार्बन, इसका इफेक्ट थोड़ा कम ही है. फाइन. सो दैट्स व्हाई C will be more acidic than B. What about A and D? Here you have this ethyl group, this electron donate. This alkyl group simply fine. This will donate electron. This will decrease acidity. Now this is neutral, neither electron donating nor withdrawing. So it will be more acidic than this. You got it? One more example, last one. Can you do it like this? If you have this one, COH, then you have OCH3, the load together oxygen. This is molecule A. Now if you have this one, simple benzoic acid. Molecule B. If you have this one, COH, it is let me say fluorine here. Now D is a C molecule. Now if you have D molecule as well, if you have this one, COOH, if NO2 is there, fine. What will be the decreasing acidity of it? Decreasing acidity of it. Acidity of it. Which one will be most acidic among all these four?
C.
Yes, sir. D.
Which one is? D, obviously. This is also electron withdrawing nitro. Fine. This is also electron withdrawing, but
Number.
NO2 group is more electron withdrawing than fluorine. The reason it has got two electronegative atoms, nitrogen and oxygen. You got it? You got it? So that's why NO2 is strong electron withdrawing as compared to fluorine. इसका ज़्यादा effect है, right?
Yes, sir.
So among these four molecules, D will be more acidic than C. Then what about A and B? Which will be more acidic? A or B?
B.
B. Which will be more acidic than A? I'll tell you why. This OCH group is alkoxy group. This also electron withdrawing, donating.
Donate.
This will give electrons to the ring. As a result, OH bond will be strong, right? So it will not easily lose electron. It will not easily lose OH, this H plus side. You got it? This alkoxy group is electron donating group. It will show plus R effect, plus resonance effect. You got it?
Yes.
It will donate electrons. Now, इसमें कोई group attached है ही नहीं, so obviously this will be more acidic than this. So among these four, this D will be more acidic as it possesses strong electron withdrawing group. Fine.
Yes, sir.
Followed by C, followed by B, and then followed by A. Right? So all you have to remember is that you have to once, if you have any question regarding this acidity of carboxylic acids, you have to look for the number of nature of group attached, कौन सा group है, whether it is electron donating or electron withdrawing. The second thing you have to remember is that number of electron donating or number of electron withdrawing groups attached. You got it? So let me take one more example, last one. If you have this molecule H, C double bond O, OH. Molecule number B, CH3, C double bond O, OH. Like this, you have C double bond O, OH. D part is CH3, C, CH3, CH3, C double bond OH. So what will be the acidity, decreasing acidity of it? Which one will be more acidic?
A, B, C, D, C.
Obviously A. Fine. Followed by
B.
followed by
C.
followed by अब यहाँ कैसे explain करेंगे हम? On the basis of number of electron groups. Got it? So nature of question can vary. Fine.
Yes, sir.
You can get different types of questions. So यहाँ पे क्या है? यहाँ पे एक electron donating group है. यहाँ पे कितने हैं? दो. Fine. ठीक है? यहाँ पे कितने हैं? तीन. So there are three electrons, strong electron donating groups. यहाँ पे कोई है नहीं, so this will be most acidic. You got it? Any question?